here in STEM Academy. What I chose to focus on is researching and building my own underwater signaling system. Something most people don't think about is things like Wi-Fi, Bluetooth, and radio waves can't travel through water. While that may seem like not a huge problem, this can have huge implications. Things like submarines and drones often have limited to no communication back to the surface. If you look, you can find all sorts of videos of underwater drones exploring, but they're always tethered, and that limits them significantly. There's also issues with scuba divers in emergency situations where they can't communicate. I did a lot of research to try to figure out some possible solutions for this. The main two things I looked at were using light and sound in order to send data wirelessly. Light, you could use flashes of light to transfer data, and this would be fast, but this typically needs direct alignment, and things like muddied water would affect this significantly. Sound is the other thing I looked at. You can encode the data in frequencies and use different timings to send a message or receive something. This requires less direct alignment since sound waves dissipate, and the water clarity doesn't matter, but then you have impacts from background noise. So I initially wanted to pick sound and wanted to see how I could do that. So the first iteration of my project, I had 4 parts. In the end, I had an app where you could type a message out. The app would then take that data, convert it to frequencies with different timings, and it would send it to a underwater speaker. That speaker would receive the data from the app and play those frequencies. On the other end, you had a microphone that could pick up those frequencies, and then something called an Arduino, which takes those the data, filters it out, converts it to the frequencies, and then decodes that into a message. So you could type out a message on one end, and then on the other end, you could see that message wirelessly through the water. I tested this a lot. I initially started in a bin of water to get a lot of the basics down. I moved into a gutter to test how it would go in long ranges, and then I moved to the pool to see how a big open water affects the system. This initial system could send messages pretty well, but it was heavily impacted by background noises, and the microphone wasn't the strongest. So for the next step of my project, I really wanted to, I took this data and I identified the biggest issues, which I identified was the microphone, and then built upon that. So this year I took what is called a piezoelectric sensor. This takes vibrations and converts it into digital signals. I built a waterproof enclosure for this, and an amplification system that could then take that and convert it to the system. So this picked up the signals. It was then amplified and then sent to the computer. One of the ways I wanted to apply this was creating an emergency beacon. So this has a series of the microphones that then, when there's an emergency, someone could hit a button that would send out that signal, and then based on that, I could identify what the signal was, so you can have different frequencies meaning different things, and the direction of it, so you can identify their location. Thank you.